Alright, in this video we're going to discuss how to do some really basic, well, it'll start really basic, make it a little more complex, really basic Python programming. Uh, so if you've been following our other videos, we're in VS Code, we've got a repository called testing, uh, and right now it is blank, just nothing in it, which is fine. Uh, so we will say testing, we want to create, nope, sorry, we want to add a new file to testing. In this case, we're going to be making a calculator, and we're going to be doing it in Python, so we will call it calc, whatever, you can call it whatever you want. I'll just call it mine calc.py, and you notice, when I type in calc, it's got those kind of bars next to it, which means it's just going to be a basic text file. But as soon as I add the .py, it changes to the little Python symbol. So VS Code knows exactly what this file is going to be and what to do with it. So we hit enter, we make calc.py, meaning it's a Python file, and we get a brand new empty Python file ready for whatever we can think up. So what does a calculator do in its most basic sense? Well, in the most basic sense is it takes two numbers, and we'll say it takes those two numbers and adds them. Okay. So what we'll do is we will say, we'll make a variable called first number, and the first number will be a variable from a input. In the input text, we'll just say first. Okay, just bear with me here. I'll explain what all this means in just a second. Print str of first number. Oh yeah, it probably helps if I spell first correctly. Okay, so I'm just going to save that and run it, and then talk about it. So I wrote these two lines, hit the play button, and it opened up a terminal, and it says it went to our files, it found the calc.py, and it is now running calc.py in a Python, running calc.py in a Python terminal. And the first thing it does is it says first colon, and it's waiting. So, well, what's it doing? So what I did here was we created a variable called first number, and first number will be equal to a user input, which is what this input means, but normally calculators are easier if you know what it wants. So for the input, we provided it a string. So it's saying, we want an input, but let's write this string out first, so that way they know what the input should be. So that's what it's doing here. It wrote out first, and now it's waiting for me to give it an input to this string, and it will take that input and save it to first number. So let's give it 6, and hit enter. 6, and then it ended. The code's done running. So I gave it a input. It said first, I gave it a input, which was 6, and then it made first number equal to 6. And then we printed out first number as a string. Just for the sake of demonstration, if I just told it to print first number, ran it, and gave it a 6 again, it would still work. Just for later, writing it that other way will be useful, but we can just leave it this way for now. So print first number, we can see that it got a 6. Let's run it again. Let's give it a 562, and it prints 562. Wonderful. So Python, we can now take an input and save it to a variable. That's a good start. But calculators usually can't do much with a single input, usually. So we will want a second number, but that will also be equal to a input, and we want a way to distinguish the first input from the second input, so we'll say second, just like we did before. And then, again, just like we did before, we will print out what is that second number. Go ahead and run. The first number, we'll make it 3, and now it wants the second number. We'll give it a 7. Prints out the first number, which is 3, prints out the second, which is 7. Means everything is working fine. Because remember, this runs in first line, second line, third line, fourth line order. So it got this, and then it immediately asked for the second input before printing them. That's so if I took this print line, if I got rid of it and I moved it up here instead, again, it moves first, second, third, fourth in terms of line number. It moves in that order. So if I run it again, it'll ask for the first number, give it a 3 again, and it will immediately print the 3 and then ask me for my second and then print it. Just for sake of demonstration, I would recommend leaving it like this. Okay, and what exactly do we want to do with this? Well, first thing we will do is we will say we'll make a variable called value, and it will be equal to, we want the, we'll do addition. So value will be equal to first number plus our second number, right? Okay, so we already know what these do. So we'll go ahead and we'll go ahead and delete that one. It will change this to value. So now, because we already know that this works, and we know that this works, so we should really just get away with printing whatever the value is, right? So we're doing value is our first number plus our second number. And let's run that. First number will make simple numbers, 2. Second number will be 3. We should get 5. Well, hey, that is not correct. 23. 2 plus 3, last time I checked, that's 5, not 23. So, you know what, maybe it just screwed up. Let's try again. Let's do 1 and 9. It should be 10. Nope, it's giving us 19. So, what's the problem here? Well, so the issue is, up here, first number is coming from whatever our input is. However, whenever we give it an input in here, like we type in a 1 or we type in a 9, Python does not realize that we are giving it numbers. It thinks we're just giving it characters that look kind of funny. Don't look like normal letters, but whatever, it's a character. So it's just putting them together. It's just taking the 1 and it's putting it together with the 9 as if they were 2 letters. So if you replaced, here, let's see. So if you replaced first with a C and second with a D, ta-da, it makes CD. Well, that's not what we want. We're giving it numbers. We're not giving it letters, but it thinks we're giving it letters. So if we print it out, so if we go here and we tell it to print out the, let's see, I believe, type of first number. Okay, so first we'll make it 9 and then a 2. So yeah, it thinks that our 9 that we're giving it is a string, not a number, which is why all of this isn't working. Fun fact, you can put in type and then your variable name in parentheses, and it will tell you what the type of that variable is. Okay, so change that back to value. And we can now see that, well, if we're adding strings, that's not the same as adding numbers. So what do we do? Well, we will need to cast these. So casting. So it's a string, but instead of it being a string, we can do what they call cast it. Well, that wasn't the best way to do that. To an integer. And then we can cast it to an integer. So now it'll take those strings, well, what it thinks are strings, and will turn it into numbers and then do the math. So it'll take it from a string, cast it to an integer, and then do the math. So let's try this again. Let's do our 9 and our 1 again. Hey, there we go. 10. That's good. Just for goodness sake, we'll do a 2, and we'll do a 3, 5. Good, 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 good. So Now it's taking in our integers and it's adding them, and we are printing out our value, and everything works just the way we want it to. So that is a very, very, very basic calculator. If we wanted to make it look a little nicer, we could tell it to print out a string that says your value is colon space, and then put in a comma, space, and then value. And then it will print, then when we run it, we can say 2, 3, and it will say your value is 5. Makes it look a little nicer for whoever's using it. Another way you could do it, but I don't personally like, is you could say plus, and then cast our value to a string. So if we cast our value to a string, it can add this string to this string like we were doing before, and it will give us the same exact thing. I personally don't think this looks as nice, but wrong button. But of course, everyone's got different opinions. I just say comma space, lovely. Okay, so that's good. Very basic calculator. We made it look a little better, but last time I checked, calculators do more than addition. At least the last time I checked. So what do? Well, we wanted to do more than addition. So maybe subtraction would be next. But what would be the best way of doing that? Well, here's where a if statement comes in very handy. So first, we will want to take in another input that will tell it what kind of math we want to do. So we'll call it math, and it will be an input. And just for simplicity's sake, we'll make it ask us math, just like that. Okay? So that's good. So now it asks us our first number, our second number, and what kind of math we want to do on those numbers. Okay. So now, the handy-dandy if statement. So we can say if our math variable is equal to, if you want to check if something is equal to, it has to be a double equal sign. If you just use a single equal sign, it will not work. Just coding semantics. So if math is equal to a plus sign, because remember, we're passing it in a string, so we want to keep it as a string. So if math is equal to a plus sign, colon, enter, you'll notice that it is now indented. Python works a lot with indentions instead of another language like, this is a little bit of a tangent, but if we did this in Java, one way you control what all happens in the if statement is you would add a curly brace. You would do curly braces. As far as I'm aware, and it would look just like this. As far as I'm aware, Python really does not like curly braces in this sense. It just prefers working with a colon and then keeping things indented. Again, each language is different, but it's semantics. So if our math input is equal to a plus sign, well then we will want our value to be equal to, here we can just copy this line. We want our math value to be equal to our first number as an integer plus our second number as an integer, right? Okay, well, what if it's not a plus sign? Well, then we can do what's called a else if. This is basically just a slightly nicer way of writing another if statement. So we can say math is equal to if it's equal to a minus sign, then we will do the same thing as before, but just change this add to a subtract, and then print out whatever the value is. So let's, very simple change. All we did was get one new input and use a fancy if statement, and we just doubled the complexity of our code. So let's go ahead and give it a run. We'll keep it simple, and we'll do 5, 5, and we will add them together. And it says our value is 10. Good. So run it again. We'll do 5 and 5 again, but this time let's subtract them. If we did everything correctly, it should be 0 and not 10. Awesome. And now, if we want to keep on increasing our complexity, well, it's just as easy as make more if statements. So let's say if, what if our math is equal to a multiply sign? Well, easy enough. Take our numbers and multiply them. Or if, what if our math input is equal to the division symbol? Once again, same thing as our addition, just change the plus to the little divide bar, and it will figure all this out. So our plus and minus should not be changed. So let's go say 5, 5, and let's multiply them. We should get 25. Beautiful. Let's run it again. 5, 5, divide them. Should get 1. Perfect. So this is really good. However, what if we wanted, again, to make it even more complicated? What if we didn't want to do just whole numbers? So, for example, actually, scratch that. So I ran the code. Right now it's waiting for an input. If I want the code to just stop, you can hit Control C. The same shortcut, macro, whatever, as a copy, and it will kill whatever code is currently running as a keyboard interrupt, which is really handy. Just a heads up. So, what I was saying is, well, what if, let's make this easier to test. I don't want to have to keep on going up here and rerunning it every time I want to do math on it. Well, how do we fix that? Well, there's something very handy called a while true statement. So let's go ahead and move that down. While, colons, or parentheses, sorry, capital T, true. And then a colon, just like an if statement. So, it kind of sucks, or at least with this, that indentions are so important. There might be an easier, get out of my way, there might be an easier way of doing this than going through line by line and re-tabbing everything. If there is an easier way, I'm not aware of it, but it's whatever. It's a little annoying. So, what does this do? Well, this says, while true, run everything that's indented below here. So this will run forever. While true, true is always true, which is true, and it's true. So true, keep running. Make it make sense. This is the traditional way of writing a forever loop. In theory, if you wanted to, you could always say while 1 is equal to 1. That will do the exact same thing. It will run forever because 1 is always equal to itself. But the traditional way to do it is just say while true. So this will now run through everything that's indented forever, at least until we Control C and exit the code. So, what does this mean? So, let's run it. So, first, we'll give it a 5 and a 5, and we'll add them and hit enter. It'll do our print statement and say your value is 10. There's nothing else below it, and it will immediately go back to the top of the while loop and ask for another first input. So let's give it 6 and 6 and subtract them. 0. It wants another first. Let's give it a 7 and a 3 and we'll multiply them. 21. Boom. Another first. An 8 and a 2 and we'll divide them. 4. Okay, well, perfect. And it will keep on asking us over and over until we Control C and kill it. So it's a little bit closer to a real calculator where you can just keep on plugging in numbers and it will keep on spitting out answers rather than constantly going up and hitting rerun. So yeah, that's just for a little bit of simplicity's sake. So now back to what I was asking us before. So what if I did 5.1 and 2.9 and I add them together? So that should be 5, 6, 7, 8. Well, nope, sorry, 5. Yeah, 5, 6, 7, 8. It should give us 8, right? Oh, no. It didn't like that. Well, why not? Let's see. Value int first number. Invalid literal for int with base 10, 5.1. So what this is saying is it basically doesn't like the way we did it. We used a integer. And for example, integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the whole numbers. However, in coding, a decimal number is not the same. For decimal numbers, we have to call it a float. So instead of an int, a float. Now let's... Float basically means floating point integer, meaning instead of 5, you can include decimal spaces. Or decimal points, sorry. So let's do it again. 5.1, a 2.9, add them together. Awesome. Now it knows it's 8, because now instead of these being integers, they're floating point numbers, and it can handle the decimals. But notice, we didn't put float in for subtraction. So if we do our 5.1 and our 2.9 here, and then tell it to subtract instead, it's still confused. So just to make it handier, I go up here, float, copy, and we're just going to go through and paste it in. Awesome. So now every single math function we have can now handle decimals. That's so much better. That increases our complexity by so much. And luckily, code is very fast. So if we say 15 point blah 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 blah, make up some numbers. 6 point, give it some decimal places. You tell them to add those. It can do it very, very fast, which is nice. Okay, so that's fantastic. Yeah, so we just made a more complex calculator, and in theory, you could even make it much more significant. So there's a library there's things in Python called libraries that you can include to your code, and it's basically advanced code that someone else has written, and it's made to make your life as a coder easier. So we can import a library called math. Just a heads up, whenever you're using imports, you can import it once and just leave it up at the top of the file, and then you can use it anywhere else in your code. So let's import the math. What if we want to make this even more complex? So we'll say elif. What if our math variable is equal to sqrt? Well, that means we would want our value to be equal to math dot s. Ooh, uh-oh. Okay, so in math, let's change this to math input. I forgot that if they have the same name, they will get upset and they won't know which one we are talking about. Okay, so there we go. So the problem was they were both called math and they were conflicting with each other. So when I was saying math dot do something, it was thinking it meant our input that we gave it, and it wasn't working. So let's see if that helps. So value equals math dot, there we go, that's everything we want. So sqrt, there it is, math dot square root. Square root of what? Who knows? Let's just make it, for simplicity's sake, our first number. Yeah, let's just do the square root of our first number. So let's rerun this. So first number, we'll say, oh, what's something easy? We'll give it 81. And our second number, in this case, doesn't matter. We'll give it a 2. And we want it to do SQRT. So now it'll take the squirt, SQRT, squirt, or square root of the first number we gave it. Square root of 81 should be 9. Uh-oh. Must be a real number, not string. Well, what could that mean? Math.squirt of first number. So, it's the same issue as up here. We did not cast first number to a float beforehand. So let's cast it to a float. Rerun it. Let's give it 81 again and whatever we want and tell it to do the SQRT. Your value is 9. Lovely. That is correct. And this math library is extensive. So you can do arc cosine, arc cos, arc cosh, arc sine, tangent, ceiling, cone, cosine, degree, dist, a bunch of stuff that I'm not even sure what it means. Floor, factorial, fabs. Ooh, let's just one more example, just for the fun of it, just to see how gross it gets. What if our math, nope, that's not, math input is equal to fact. Well, if that's the case, we will make value equal to math dot factorial. Factorial. What inputs does it take? Okay. Raised a value error if x is negative or non-negative. Okay, so it will do in factorial. So let's take the factorial of our, whatever we want, our second number. But remember, cast it to float, like that, and then let's run it. So we're doing it off the second number, so who cares about the first? Let's make it something simple, like 3. And we'll do 3 factorial. Float object can't be interpreted as an integer. Okay, well, in this scenario, factorial can only take, didn't read that. It can only take a integer. So in this case, we won't want to cast it to float. We'll want to cast it to int. Okay. I didn't know that. So let's retry. 11, whatever, and then 3. Math, do factorial. Ta-da! 3 factorial is 6. How far can we push it? Let's do 10 factorial. Well, that calculated it pretty fast. But, oops. But factorial can grow pretty quickly. So what if we do 200 factorial? That's a big number. So in theory, if we make our number big enough, let's say 5,000 factorial, we'll most likely have to Control C and kill this code. I don't know if it can handle 5,000 factorial. Oh, yeah, okay, so it's saying it can't handle that. It cannot do something that massive. I wasn't sure if it was actually going to try or if it was just going to error, but it looks like it didn't even try. But that's okay. So that's an instance where we need to cast to an integer instead of a float. So yeah, this video went on a little longer than I anticipated, but here's a way you can make a fairly simple, straightforward, yet cool calculator in Python, and have the potential to expand it with elif statements and math import and make it as large and complex as you could possibly want. And I might make another video to where we add even more complexity and make it look even cooler. Who knows? But anyway, yeah, thanks for watching.